Okay, welcome back. I had some audio problems the last time, so I hope I resolved all of them. So, where were we? We started with controlling our stepper motor from the through the HTTP API. We could do a get from the root, and if I did that, it would rotate for a bit. And let's continue from there. Two things I would like to do today. I would like to ease in and out the motion a little bit. So now it starts really suddenly and stops really suddenly. There's very little connected to it, but so then it's fine. But if it's heavier, then you want that. Second, I want to be able to control the speed, acceleration, and the distance all from the HTTP. Now I just can do one thing, and that is the only thing. Let's get started. So for the acceleration part, I don't really want to do the math myself. So there is a library called accel-stepper. It's from a guy named Michael Bryan, but it hasn't been touched in 4 years. It's actually a sort of a port from Arduino. So it was an Arduino library, and he ported it to Rust, I suppose. And I asked him a while back if he was interested in pull request, because I missed some things and I just couldn't get it to compile, which is no surprise given that it's based on 4-year-old dependencies. Actually, on the IDF and one of the earlier episodes, it did work, so it was better than I expected. But yeah, so I needed some change, so I forked it. Let me see. Yeah, I forked it just to get GitHub. Didn't change much, just a few details, and most importantly, I updated the dependency so it would compile. So, how does that go? The nice thing about that accelerator library is that it has very little dependencies on the hardware. It doesn't assert that there are 2 pins or which pins or even that pins exists. It's just a thing that you call a lot of times, so as frequently as possible, and then it will either step the motor or not. And that's how it controls speed. So if you ping it like 1,000 times per second, then it will step every time or some of the times depending on the speed. So there is very little. Oh, wait. Yes. Yeah. There's very little. There's very little integration with the hardware. So that's something we're gonna need to do ourselves, which is some work, but it's not terrible. So it starts by adding the dependency, obviously. So let's do that. Let's add it, and we call it accel-stepper, and we need to get the Git repo. I think just this. I haven't released it on crates. I don't really think it adds enough, but if someone likes that, I can do it. And the revision. This one. Let's see where that lands us. That seems alright. This weird import. We can remove it. These 2 files aren't used also. We can delete those 2. Alright, so now, if I'm not mistaken, accel-stepper is available. Perfect. So first of all, what we need to do is to create a device. And what is a device? Let's create a separate file. We call it stepper.rs. We include it here, so let's say around here. Mod stepper. And that device is a struct. We call it stepper. That device needs to have some pins. So we need our direction pin and our step pin, right? So let's add those. So we had these. So let's say direction pin is of type GPIO 1 in this case, output push-pull, and we have our step pin, that's GPIO 2. Let's see, why is it unhappy? Yeah. It needs to import. Okie doke. Let's create a implementation block just to create a constructor. New, returning self, and we create a stepper, and we take the same thing as parameters. So let's say dir pin and step pin. Okay, let's make it public. So now this thing does nothing. You just give it the pins. So we move actually the ownership of the pins inside this structure. So now we need to implement the device, and the device is kind of the back end of the acceleration API. So this is how it will actually do steps. So we implement it for the stepper, and then we have to implement this this method. So this method will be called whenever the accel stepper wants to make a step. Let's keep this empty. We're not going to use it. So what does that mean? Well, first of all, we need to figure out. So in this case, the stepper says I want a step. So what do we do with the pins? First of all, we need to know which direction we are going. If in the context we have some parameters like position, target position, step time. So if we can use the position and the target position to see which way we are supposed to be rotating. So if the position is smaller than the target position, then let's say we're moving clockwise. And then we put on the direction pin. We can set it to high. Set high and wrap. And otherwise we set it too low. Set low. So after that we need to do a step, and a step is a very simple thing. A step is a self step pin, and we toggle it. something. And then we need to return something, so we say okay. Right, so if we offer this to the accel-stepper, then this will work out. What is next? So we have this backend now. Let's go back to the main and go into the motor function, and there we can instantiate kind of the front end of the driver, so which we control, and that's called driver. accel-stepper driver. It has a default, right? Yeah. So what does that do? So we can send it commands, move by, move to. We can query some things like, is it running? How much distance does it have to go? Acceleration, current position, that kind of stuff. And we can call poll. And poll is the important one in this one. Well, they're all important, but so poll we should call as often as possible. We pass in a device, and we pass in a clock. And a clock is something that the accel-stepper needs as well, because it's not gonna assume that there's a clock at a particular hardware thing or something like that. We need to give it, and for that we need to create something very similar as we did before with the device. But also I think we created something very similar for the Picoserve that needed a timer as well. So yeah, it's very similar. A lot of components need a timer. Let's make one in the stepper, I suppose. So we need a timer. The timer needs something in this case, right? So we're gonna create a struct, and we call it the ESP clock. Well, ESP32. So it's a real-time clock. It just indicates a time, a linear time. So if we go back here, if we go, let's see, can we see that? So that clock type doesn't want to highlight. We'll get there. So we have a struct, and what we want to do, we want to implement. Let's be nice and create a constructor. We'll get to that, and we need to implement system clock. That's the accel-stepper trait that we need for ESP32. Let's see what it needs. And the only thing that it wants is a duration. And that's the duration since the beginning of time, whatever that exactly means. It's only matters like how much time elapsed between the last time it called this. So it can be from the beginning era of Unix or something like that, or just since the device started. That doesn't really matter. Important detail: this is a core time duration. It's different than a duration from the embassy, because we use those all the time, but it's a different one. So we need to keep that in mind. So what can give that time for us? Well, we can create one. There is a RTC new. Let RTC is RTC Do we have something like that? Yes, that's from the HAL. And what do we need for that? Let me check. And I think that's in peripherals. Yeah. Okay, so now we have a RTC object. And let's give it an explicit type, and we can say that it's static, I think. It's not going to go away. So we have this object. Let's pass this to the motor function. So this thing is going to travel all the way. I prefer that than moving the peripherals or something like that. So RTC, no, that does not make sense. So RTC, and then here we add it as a parameter. Okay, so now we have that RTC, and then we can create a clock. Let clock equals ESP32, we call it, I think. Let me check. We need to make it public. And we need to pass in the RTC. And we need to store it in our struct. So we do a ESP32 with RTC. Alrighty. So now we can use this, and we say self dot RTC dot get time microseconds, right? And that will just keep on increasing. We need to create a duration out of it, so we do a core time duration from micros. Here we go, one system clock. So here we were creating, what did we call it? Yeah, we did call it ESP32. What's wrong? Let clock equals ESP32 new, and we pass in the RTC we got here, right? Yeah. So we have that. Now we have to create a device we created before, well, we defined before. So we had the stepper, right, which implemented device. So let device equals stepper no, stepper, yeah. Just call it stepper. I'm just being a mess. Is it not public, maybe? Yeah. Alright. So we say stepper new, and that will need those pins, right? So we say direction and step. Okay, so now we created all the things. It wants. So this is now not going to work anymore. It says it can't use the step and the direction pins anymore because we basically gave it away to the device. So what we're going to do, let's wrap this a little bit. So I'll just receive the command. So we have a move command structure. I'll delete all this for the time being. And then what I'm gonna do is I'm gonna do a loop, a while loop, and no, first I need to issue a command to the driver. So I will interpret it as a relative command, so I can do driver move by, and I take command dot distance. So now I'm saying to the driver I want to move a certain distance, probably need to cast it. Alrighty, and next what I'm gonna do is I'm gonna do a while loop. Driver dot is running. So as long as it's still running, I'm gonna call driver dot poll, and I'm gonna pass the device and the clock. Okay. That seemed to work, and then I need to do some awaiting. So, well, 100 microseconds, so it's 10,000 a second. Maybe a little bit much, but we will see. What's wrong? Move value device. I think this just needs borrows, and I guess a mutable borrow. No, because it's not mutable. Yeah, okay. And now what? The wrong one. I guess that one as well. Okay. This needs an unwrap, I suppose. I guess these ones don't need to be mutable anymore. Okay. Yeah. We will need to set up the driver a little bit. So let's set a max speed, for example. Let's put it on 8000.0 to appease it. And set acceleration to 1000 maybe. So it's a bit, we know it's in a sane state at least. Okay, let's go. Let's flash this thing. Okay, connected to the network. Let's see what this does. Can use this one. Yeah, can you tell? It starts slow and then it starts speeding up and it slows down again. Nice, I like that. So it's a lot more smooth on its operation. Yeah, you have to bear in mind that, for example, if you increase the speed a lot, you need to have this frequency needs to be high enough, right? It's never going to do more pulses per second than this loop is going to do. So there is a limit there. I can imagine there is for Embassy there's a more efficient solution for that, but for now this seems to work. So that was part one. Part two is what I wanted to do is to get a bit more into getting a bit more information in it, because now we just had one hard-coded value that just moved it in some direction. But I would like to be able to really push whatever I want to do to the endpoint, right? So if you know a framework like accel, which is Picoserve is quite inspired by that as well, and it all works with extractors. So for an extractor, you need to you can just add a parameter with the right extractor, and then the framework will kind of figure it out. It's maybe a little bit more magic than I would generally like, but it works pretty well, and it's a pretty straightforward once you get the hang of it. And it looks something like this. So what we can do, we can introduce a new parameter, and let's call it payload, and that's of type form and move command. What does this say? Probably, and this is one of the, it needs to implement deserialize. It's quite nice that it had actually a pretty clear error message that it talked about deserialize, because often when things go wrong you end up with totally obscure error messages. So we ended up with a payload of form, so we can deconstruct that. We do form payload. And then, so now we have it deconstructed, and we just have a move command right there. So we can just remove this and add payload. So this uses form encoding, which is not my favorite, but it's okay. I'll work on the JSON version later. But yeah, so that means that in order for this to work, we need to have a form that's compatible with the structure of this command. Let's make it a bit more interesting. Let's add a speed, also I32, and the acceleration, call it accel. Let's be a little bit realistic here. So we have a distance, a speed, and accel. And if we post a form, or get a form for that matter, with those fields, it should all work out. Let's see what this does, right? Oh yeah, we still need to use those fields, of course. So we send this through the channel. In the channel, the motor gets a command, and now we did the move by for the distance, but let's first, we can just move this one, because this is no longer necessary. So every time we receive a command, we're going to set the speed of the command dot speed as F32, I think, and we say here command.accel. Okay, I think that's it. Let's flash it. Okay, so it's listening. Now I think if we do this, it says bad request, which is kind of cool in the sense, right? That it has some error checking here. But what we need to do, and I have it in here, that we need to use a form urlencoded, and we need to say something like the distance, the speed. That's kind of excessive, 9,000 maybe, and then we do 1,000, and then we can send it. Let's see what happens. Speeds up nicely. And slows down again. Let's now, this was clockwise, so let's go counterclockwise. Let's go a bit faster. With the same acceleration. And we move backwards. So that works quite nicely, right? So I think the limit now is this one. So I can see what happens if I speed this one up, because it was waiting for 100 microseconds, so it can maximum do 10,000 steps per second. So going over 10,000 doesn't do much. So let's try what happens if we increase that. So now it should be able to do 100,000 steps. I'm very sure that motor can't do 100,000 steps, but the board should be able to. Okay, let's see. Maybe speed it up a little bit. What that does. I'm not sure if you can hear it. It starts to make some noise now. So let's go a bit faster even. Maybe accelerate a bit quicker also, otherwise it might not make it to full speed in that time. Another thing that we can do, so you can see that it returns pretty much immediately, and because we are using a channel, right, that had a certain number, I think 10 items, we can send multiple commands. So let's send the same one counterclockwise, and then we send an immediately afterwards one clockwise. So now hands off, it will stop, and then it will process the next one going clockwise again. So we can queue up commands, and yeah, it's really nice because it's all asynchronous, so we don't need to spend a lot of time thinking about those things. So that's all. That's a nice one. I had to do it again because of audio issues, but yeah, please leave a like. I hope you enjoy these episodes. I'll do one more with the stepper, and then I'll go into MQTT. Yeah, please share a like if you have ideas or anything else. Please reach out, or you just want to talk about Rust or whatever. There is LinkedIn, there is my GitHub. Yeah, I'm easy to find. Alright, take care, see you next time.